Alright, so what I've got here are the Feynman Lectures on Physics, 3 volumes. This was a Valentine's Day present my wife got me a few years ago. And I guess Valentine's is coming up in a couple days now. But I've also got 2 planks set up. They're just from flooring. We had some extra planks there. And I try to set them up at approximately the same angle here. So the idea is that these physics books probably made of the same material, and also the planks probably have the same finish on them, hopefully. So I'm assuming that the coefficients of friction between these books and these planks are relatively equal. And these 3 books, I weighed them out. So this is volume 3 here on quantum mechanics, and it's the smallest volume out of these 3. It weighs 1,100 grams. And these other volumes are a bit bigger, so electromagnetism, and the other one is on mechanics, the stuff we're studying. And these ones are thicker, and they're about 1,500 grams each. So the books are, volume 3 is lighter, almost 2/3 as light as the other books. And I'm gonna have one each on one of the 2 planks and have them slide down, and we're going to compare their rates of acceleration. We're not actually going to measure it, we're just going to qualitatively observe it. And based on some of the calculations we were doing, I'm hoping that they're going to accelerate at the same rate down the ramp. So the mass got canceled out when we did the steps, which means that mass is actually not supposed to matter for something sliding down a ramp. As long as it's just sliding down the ramp. There's no applied forces, there's no Mr. Korsmito applying a force or anything like that. Alright, so let's see. Okay, so this one is the lighter one, this one is the heavier one. 3, 2, 1. Alright, so it was, well, knocked the camera over. So it was pretty close. I will say that one of the books actually won. If it was a race, I think the heavier book clearly won, which does not really match our calculations. But why might that have happened? Well, there's a few reasons. One, maybe the books are not exactly gonna have the exact same coefficient of friction with the ramps, because they are still 2 different books and 2 different ramps. Secondly, perhaps the ramps are not at the exact same angle as each other right now. Maybe one's just a degree or so steeper. But you know what I'm gonna try? I'm actually gonna try to do the same thing, but I'm gonna switch the books. So the books on the left versus the right, we'll swap them out. All right, so I had the heavier one on this plank, and I had the lighter one on the other plank, and now I'm going to switch them, and we'll see if that makes any difference. 3, 2, 1, go. Okay, so one book won again by a couple of centimeters, and this time it was the lighter book that won by a couple of centimeters. Okay, so I think that it has to do with the planks not being, they look a little bit warped, to be honest. So the planks are not perfectly straight at the same angle. So it looks like this plank, regardless of whichever book I slid down it, that plank had the winning book both times. Okay, the other thing I want to show you is the nudge. Been talking about the nudge in some problems. So that's basically to overcome static friction. So I've got the plank set up so that it's steep enough that it will slide down, but what if I make it a bit more shallow. Okay, so maybe, okay, it's still steep enough. Maybe how about this? All right, so now it's at a low enough angle that the x component of gravity is not enough to overcome the static friction, so it's just going to stay at rest. However, if I just give this book a little bit of a nudge just to get it sliding, then it will no longer be static friction, it'll be kinetic friction. And the value is usually lower for kinetic friction. And once that switch is made, perhaps it will accelerate down the ramp. All right, so here's the nudge. So a nudge is all I need to break the static friction, and so kinetic friction is lighter or is weaker, so it accelerates down the ramp. All right, I'm gonna try this last thing out. I haven't really tested it yet. I'm not sure it's gonna work too well with a book, but we'll see. I'm gonna give it a little shove up the ramp. So what should happen is it should slow down, because both gravity and friction will be slowing this book down. Eventually it should come to a stop. Will it slide back down after it reaches that point, or will it actually stop and stay stopped? All right, let's see. So it actually stops and stays stopped. So it's kind of reinforcing that at the very moment when it gets to the very top, it does come to a momentary rest. But when it comes to that rest, friction becomes static friction again. So friction is the stronger version again, enough to keep it at rest. And then we'll give it a little bit of a nudge. Oh, that didn't work out. A little bit of a nudge to get it going back down the ramp. All right, so there's just a couple of concepts of friction and sliding down a ramp. First of all, the mass does not matter for the acceleration, as long as there's no external applied forces on the books. And secondly, the nudge can help break static friction, turn it into kinetic friction, which is a lower number of newtons.